Hi, my name is Rosalind Dakin. I'm a biologist at Carleton University in Ottawa, and I study animal behavior. I wanted to use this open house video to introduce you to some of the behaviors that we're studying at QUBS. We're particularly interested in the ruby-throated hummingbirds, in particular how they perform their incredible flight maneuvers. I think hummingbirds might be one of the most agile flying animals that has ever evolved. They can routinely fly at 50 kilometers per hour, they can avoid all kinds of obstacles, and they can stop on a dime and hover. So we're interested in how they do this. This next clip shows zooming around back and forth. At the bottom there is a male performing a courtship display for the female who's perched on the feeder at very high speed. And I'll just play this one more time. So they use their incredible agility in all kinds of ways in the wild. This next clip is a slow motion video of a hovering hummingbird, which illustrates how hovering is actually quite dynamic. You'll see that the bird is making all kinds of adjustments with the position of its wings and body and tail to keep its head and eye fixed in one place in space. So one of the research questions we're interested in is how birds use visual information to control flight. Hummingbirds, like most other birds, can detect UV light, and so they have a much richer experience of color than we do. But because hummingbirds are so small, their eyes are quite small, and that means that they can't resolve as much detail as we can. So their spatial resolution is about as good as a nearsighted person without their glasses on. And yet they're able to perform these flight maneuvers that are both rapid and incredibly precise. So we're interested in how they do this. Hummingbirds have a number of specializations that allow them to perform their unique style of flight. For one thing, they beat their wings incredibly fast. The ruby-throated hummingbirds beat their wings about 50 beats per second. This video is slowed down. And they also have a very unique style to their wing beats. So if you watch other birds flying, you'll see that when they bring their wings back up, they'll fold and retract the wing inward as they draw it up for another beat. But if I play this clip again, you'll see that the hummingbird does something really different. They beat their wings in a figure-8 pattern. Instead of folding and retracting the wing to bring it back up, the bird flips the wing over, keeps it extended, and gets another stroke out of the upstroke, another force-generating stroke, I should say. So the hummingbird is generating force on both the upstroke and the downstroke, and that's part of what facilitates their very powerful maneuvers and their ability to hover. If we look at their inner anatomy, they have another number of specializations there. Their pectoral muscles on the breast that control the powerful wing beats are greatly enlarged in hummingbirds to support this remarkable flight style. This is the keel, which is part of the breastbone where those pectoral muscles attach, and it's really big in hummingbirds. If we look at this image where it sort of compares the skeletal anatomy of a hummingbird and another bird, you can see how exaggerated the keel is. Second, we can look at their wings. In this image, you see the wings of 5 different species of bird that range hugely in size, and so the images are scaled to fit on the same page. And on the left of each wing here, it's the upper arm, and on the far right, it's the hand. And then the hummingbird, the calliope hummingbird, is shown at the top. And so what you can see is that the hummingbird's wing is almost all hand, whereas their arm bones are greatly foreshortened. And this is necessary for the wing muscles to be able to perform those super fast contractions at 50 times a second or more. Also, having foreshortened arm bones keeps the wing very light. Now, the hummingbird's flight style is also incredibly energetically expensive. In fact, hummingbirds have the highest energy consumption per gram of body weight for any animal. They need to consume 5 to 10 kilocalories a day, which is a lot for an animal that only weighs 4 grams. They fuel this by feeding on flower nectar, tree sap, and some insects. And if you could scale a hummingbird up to the size of a human, that metabolic requirement would be as though you or I needed to drink 400 liters of juice a day or eat 100 pizzas. So, of course, they need to be able to remember the locations of hundreds of flowers to support their nectar habits. And so, one of the other research questions we're interested in is what strategies do hummingbirds use to search for these rewards? This short clip is from an experiment by one of my students. And in this array of artificial flowers, only 3 of these flowers hold a sugar reward. And the bird is easily able to learn the locations of these 3 rewarded flowers. The area around Lake Opunakon is ideal for ruby-throated hummingbirds, and the best time to see their activity is during migration, when they're a lot of them and they're competing with each other for fuel. And so May, August, and September are the busiest months, and it's never too late to put out a feeder. I want to leave you with just a couple of other clips of some hummingbirds fiercely competing with each other during migration. This is a female warding off a competing male. And thanks for watching, and I hope I see you at QUBS in the future.